Here we're going to be just really quick reviewing what we've learned so far about circular motion. So whenever an object is moving in a circle, instead of using the X and Y position to describe where the object is, we're going to describe where the object is on the circle in terms of an angular position. So we look at where the object is, we can draw a line from the center of the circle to the radius, and then we just look at the angle that's made between that line and the positive X axis. That gives us our angular position, and that's measured in radians. As the object is moving in a circle, we can measure how big its angular velocity is, omega. Angular velocity measures how many radians of the circle the object is moving through each second. And just remember that the total circle has 2 pi radians. So our angular velocity is saying how many radians are you moving through each second, per second. We can also use units to measure angular velocity of revolutions per second or revolutions per minute. Those are all units to measure angular velocity. Now, if our angular velocity changes, if it gets bigger or smaller, if we rotate at a faster speed or a slower speed, we will also have an angular acceleration, alpha. And alpha just measures how fast our angular velocity is changing. We define the counterclockwise direction as positive. That way we can differentiate between something that's moving in this direction and something that's moving in this direction. And then we can also relate other quantities such as our tangential speed or our tangential velocity. Here this is my tangential velocity. That can be related to my angular velocity by just multiplying the angular velocity by r. This value is telling you how fast the object is moving. The units here are just meters per second. And then if our angular velocity is changing, that means our tangential velocity is also changing, in which case we would have a tangential acceleration. The tangential acceleration can be related to our angular acceleration by multiplying by r. So this is kind of what we've done so far in terms of kinematic variables. Let's consider again this object moving in a circle at a constant speed, and I want to know, is it accelerating? So press pause, think about this, think about what does it mean to accelerate, and then press play when you want to see what the answer is. Now in this case the speed is constant, but the object is always changing its direction. So its velocity is changing in time. Whenever your velocity changes, you do accelerate. So this car is accelerating. Even though the speed is constant, it is accelerating because it's changing direction. And so far we've kind of said, if the object is moving in a circle at a constant speed, we've described that as uniform circular motion, and we would say that alpha is 0 and our tangential acceleration, a sub t, is 0. But there still is another type of acceleration going on. So let's explore what type of acceleration is happening here. So just as a review, anytime your speed changes, there is an acceleration. Anytime your direction changes, there is an acceleration. So we've seen this before a few times. Here's an object speeding up. Whenever you speed up, your acceleration is in the same direction as the velocity. Here is an object that is slowing down, and whenever you slow down, your acceleration is in the opposite direction of your velocity. Here is an object that is turning. The speed has not changed. It's still going the same speed. However, it has turned, its direction is changing. That means that we did accelerate. So what is the direction of the acceleration in this case? Well, if there was any bit of the acceleration up in this direction, we would speed up. If there's any bit of acceleration down like this, we would slow down. But we're not speeding up or slowing down, so there's not going to be any acceleration that's in this direction parallel to that velocity. That means that my acceleration is perpendicular to my velocity. If you accelerate perpendicular to your velocity, you're going to turn, but your speed will stay the same. So let's just review what we talked about with uniform circular motion. Here's an object, it's moving in a circle at a constant speed. This tangential speed is constant. This angular velocity is constant. If this is constant and this is constant, that's wrong, sorry. That means that I have no tangential acceleration. My tangential acceleration is 0 because this value is not changing. My angular acceleration is 0 because this value is not changing. Just a reminder, tangential acceleration measures how your velocity changes and how fast that happens. And your angular acceleration measures how fast your angular velocity changes. Those things are not changing, so these accelerations are zero. But as we just showed, because this object is always turning, there is some type of acceleration. It's not accelerating tangentially. It's not accelerating in terms of its angular acceleration, but it's going to accelerate towards the center of the circle. Notice how this acceleration is perpendicular to this velocity vector here. Okay, that means that whenever your acceleration is perpendicular to the direction that you're moving in, you will turn. So there is an acceleration. This object is accelerating towards the center of the circle. This is a very specific type of acceleration. It's so special that we have a very special name for it. It's called centripetal acceleration. For now, I'm going to call it a-cent, like centripetal. Later, I'm going to change that name. This is simply the acceleration towards the center of a circle. When an object is moving in a circle, it is always, always, always accelerating towards the center of the circle. That's just true because it's always turning. To keep moving in a circle, it's always, always, always turning. So it's always, always, always accelerating towards the center of the circle. And we call that acceleration centripetal acceleration. Now I'm not going to go through the derivation of this. The textbook does, but it's pretty confusing. So what I want you to know is that your centripetal acceleration depends on how fast you're going and the radius of the circle that you're making. Okay, so this is my tangential velocity here, and this is the radius of the circle that I'm going in. So your acceleration depends on these two variables. If you're going faster, 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 meaning if your speed is bigger, your centripetal acceleration would be bigger. If you're moving in a circle that has a smaller radius, your centripetal acceleration is bigger. Since we have a mathematical relationship between our tangential velocity and our angular velocity, which is just, remember, v sub t equals omega times r, I could also write my centripetal acceleration in terms of omega and r, and here it is. So this is what that acceleration is equal to, and we're going to use this a lot going forward.